All right, everybody. Thanks for coming back here. We're going to finish today our talk about surface area of three-dimensional figures. Today we're going to talk about the surface area of spheres. Let's start by first describing what a sphere is. A sphere is a set of points in space that are a fixed distance from a given point called the center. Okay? So think of it like a three-dimensional circle. It has a lot of the same things a circle has, such as radius, a diameter, a circumference. A radius of a sphere connects the center of the sphere to any point on the sphere. So you can see in the picture on there, we have one of the infinitely many radii that sphere has. A hemisphere is exactly half of the sphere. So if you take a sphere and cut it directly in half, you get two equal hemispheres. And if you do that, the top of those hemispheres would be a great circle. So you can think of a hemisphere as just billions and billions of circles stacked on top of each other. The biggest circle possible is called a great circle. Okay? The important thing about a great circle is that it shares a lot of features with the sphere. The great circle and the sphere have the same radius, have the same diameter, have the same circumference. So the surface area of a sphere, jump right in here to a formula, is 4 pi r squared. You notice there isn't a formula for lateral area. Okay, because spheres don't have lateral area. They don't have lateral sides. They don't have sides at all. Just one smooth circular shape. So the total surface area of that sphere is 4 pi r squared. All right, so if we're asked in example 1 to find the exact surface area of a sphere, all you know is the radius, which is half the diameter, or 38. So our total surface area is 4 pi r squared. All right, it says to find exact, so do not type the pi in your calculator, and we get this, 5,776 pi square centimeters. Number 2, find the exact surface area of a sphere with great circle that has an area of 49 pi. All right, so we have the great circle has area 49 pi. We know the area formula for a circle is pi r squared. So if the area is 49 pi, we could divide both sides by pi and take the square root, and that would give us our radius. And then we can go back into our great circle's formula, our sphere formula, which is 4 pi r squared, and we get a total surface area of 196 pi square miles. Here we have a hemisphere, okay? So there's a difference between an open hemisphere and a closed hemisphere, okay? So this one says find the exact surface area of a hemisphere, okay? And you can look at the picture here, and it looks to be like it's closed. What does that mean? It means there's a top to it, okay? So if this was a full sphere, right, we'd be doing 4 pi r cubed. That would be 900 pi. That would be if it's a full sphere. But because this is only a half of a sphere, you're going to cut that number in half. And our answer would be 450 pi square meters. All right, so if this is an open sphere with no top on it, our surface area would be 450 pi square meters. However, because this sphere happens to have a top on it here, we have to add in the area of that top. It's a circle, so it's just pi r squared, which is 225 pi. So adding the 450 plus the 225 together, our total would be 675 pi square meters. All right, basically to summarize this here, if it's an open hemisphere, your formula is going to be 2 pi r squared because half of the sphere. But if it's closed, since we have to add another circle, our formula will be 3 pi r squared. So a full sphere is 4 pi r squared, a hemisphere is 2 pi r squared, and a closed hemisphere is 3 pi r squared. All right, finally here we have the surface area of a hemisphere whose great circle has an area of 100 pi. So once again, we have area of a circle is pi r squared, and this time it's 100 pi. Dividing by pi and taking the square root, we get that the radius is 10. So if it's an open hemisphere, our formula would be 2 pi r squared. And if it's a closed hemisphere, it would be 3 pi r squared. All right. We could do both pretty quickly here. If it's an open hemisphere, it would be 200 pi square inches. And if it was a closed hemisphere, it would be 300 pi square inches. All right, that's it for our look into surface area of spheres. That will do it for our chapter on surface area.